For the Ferris wheel project, I'm going to show the example of the Niagara Sky Wheel. The Niagara Sky Wheel actually goes 53 meters in the air. I'm going to make the numbers a little bit nicer. Feel free to do the same. Again, you should choose a different height for your Ferris wheel and different speeds just to make your graph a little bit different. Okay, the Niagara Sky Wheel is about 50 meters high. I'm going to choose that speed 1 is 8 minutes per revolution. So it's going to take you 8 minutes. You're going to start at the bottom. You're going to go all the way around. The second speed, I'm going to speed it up a bit, and I'm going to put it 4 minutes per revolution, so basically double the speed. Okay? Okay, so down here I have a graph made, okay, and I want you to graph 2 revolutions, so my slower speed is 8 minutes, therefore I need to go to 16 minutes to show 8 minutes, to show 8 minutes twice, okay? I have my heights on the side, they're in meters, so 0 to 50 meters, and my time on the bottom is in minutes. So first thing I'm going to do is I'm going to graph my midline. Okay, my midline, if my wheel is 50 meters high, my midline is going to be about 25 meters. Remember, the heights don't change, just the speed changes. There's my midline. My top line, my max line, is at 50 meters, and my min line is down here at 0 meters. Okay. Okay, so the very first one, we get on a Ferris wheel at the bottom, so I'm going to start at the bottom of my grid. So at 0 minutes, I'm getting on the Ferris wheel, and I know at 8 minutes the ride is done. Okay, so I'm back on the ground in 8 minutes. Therefore, at 4 minutes, I'm at the top of the ride, and at 2 minutes, I'm midway, and 2 minutes after the middle, 6 minutes, I'm also midway. Okay, and then I'm going to do that again. So 2 minutes, I'm back to the middle, and 12 minutes, I'd be at the max, 14 minutes, back to the middle, and 16 minutes, my ride is done. So let's graph this out. Okay, so there is my graph of someone's ride, someone's height on the ride in minutes. It's stretched out over minutes as they're on the Sky Wheel in Niagara Falls. Okay, so now the challenge is to write an equation. So here, I'm going to recognize, I'm always going to start where I'm going to look at my sine function and say that is one sine wave right there, okay? So right there, I start at middle line, my sine wave looks like that all the time. So I'm going to start there. So instead of reflecting or anything like that, I'm just going to start where my sine wave starts, okay? So I have my speed 1, f at x, is equal to, well, first let's take a look at my height. My normal height of a sine function is 1, but my height here is, well, I went from 25 to 50, or from 0 to 25. So I have a stretch, a vertical stretch, by a factor of 25. Okay? Then I have a sine, and I have a phase shift. A phase shift, well, I did not start at 0. I started at 2 minutes. So x minus 2. And I am not starting at 0 either, where my normal sine function is. I'm up 25 in the air. Okay? Now, just to be completely honest, we are missing our k value, which we do not have to worry about in that course, in this course. But if you were to actually graph this out, we would be putting a different value here. We're going to pretend that this is right for now. There is a value in there that divides over a period of 360. I wouldn't worry about that right now. I just want to see if you guys can graph these functions. Okay. Hope that helps. I'm not going to graph my second function. Maybe I'll do that on help later this week, but hopefully that helps with your Ferris wheel project.